For some plants, they produce a single fruit from many individual flowers. Remember, a flower is a unit that contains the whorls: calyx, corolla, andrecium, gynoecium. In the case of a mulberry tree, you've got multiple flowers. You can see each of these is an individual ovary from an individual flower, that when the mulberry matures, you get these fruits that are derived from many flowers. So many flowers together make one fruit. That's called a multiple fruit. Pineapples are the same way, as are figs. So here's a pineapple. You can see each of these facets on the face of a pineapple is in fact derived from an individual flower. And they all kind of work together to make one big fruit. So that's a multiple fruit. So if strawberries aren't berries, what are berries? As it turns out, tomatoes are an example of a berry. Blueberries are an example of a berry. Huckleberries are closely related to blueberries. They're also a berry. What does it mean to be a berry? It means that almost all of the pericarp, the stuff around the seeds, is fleshy. So you don't have a stony pit. You just have one flower that goes into making it. So in the case of a tomato, all of this pericarp is fleshy. The mesocarp that surrounds the seeds. So a tomato is a berry. A melon, like a watermelon or a cantaloupe or even a pumpkin or a squash, these are all a special type of berry called a pepo, because they have this thick, hard rind, which is the exocarp. And the mesocarp is fleshy. Can't even really see the seeds in this one. And it's yellow, which is kind of weird for a watermelon, but what are you going to do? Citrus fruits include oranges, limes, lemons, grapefruit. They are a special type of berry with that fleshy mesocarp called a hesperidium. So that's something we only find in the citrus fruits that has this leathery rind that has the oil glands. Interesting fact, the juicy part of the hesperidium, if you've ever taken an orange apart, you may have noticed that there's little, it's made up of little sacs. And inside those little sacs, there are modified hairs that are filled with juice, those locules. So the juicy part of an orange is actually comprised of a modified hair. That's kind of weird to think, isn't it? Drupes are fleshy fruits that have a stony endocarp, or a pit. So, for example, a peach, whenever you eat a peach, you get down to the pit, and there it is. And sometimes if that pit comes open, you'll see there's a seed inside. And this seed, you might notice, looks an awful lot like an almond, because almonds are in this same genus as peaches and plums and cherries and nectarines. They're all in the genus called Prunus. And those almonds are actually seeds. Pomes are a type of fleshy fruit and our examples of pomes are things like apples and pears. And how do you recognize something as a pome? Well, you have to recognize that this papery margin here is actually the ovary wall. So this is the ovary wall here. And essentially, most people, when they eat an apple, they get to that papery bit and they're like, oh, this apple's done. I'm not going to eat it anymore. So what are you eating if you're not eating the ovary wall, if you're throwing the ovary wall away? What you're eating is a modified type of receptacle called a hypanthium. And that grows up and it envelops the ovary wall. And so that's what a pome fruit is. So apples are actually considered to be an accessory fruit because you have material that is not ovary wall that contributes to the dispersal agent. So all fruits are characterized by being the remains of the ovary wall and possibly some other accessory tissues. But the ovary wall is called the pericarp when it develops into the fruit. And it has an exocarp, a mesocarp, and an endocarp, or an outside body, a middle body, and an inside body. Let's say outside, yes, outside, middle, inside. Okay, so even in dry fruits like corn fruits, you have a pericarp comprised of an exocarp, a mesocarp, and an endocarp. Grains like corn and rice and wheat and oats are all considered to be a type of a dry fruit called a caryopsis. Other dry fruits include things like legumes, which peanuts are an example, or garden peas are another example of a legume. Okra, when it fully matures, is an example of a capsule. And milkweed, which is represented here, is an example of a follicle. And these three fruits have something in common, which is that they have an axis that is intended to split open to release the seeds when the fruit is fully mature. So like a peanut, how do you eat a peanut? You crack it open, right? And it cracks open right along the edges, one edge on each side, to release the seeds, which are the peanuts themselves. So legumes open along two different sutures. The sutures are the weak spots that open. A follicle only opens along one side, so has one suture, and a capsule has more than two sutures. So like an okra, if you let your okra stay on the vine and don't pick it, when it's green and not quite ready to have viable seeds, you'll see it split open looking like something like this. Samaras that I mentioned before with maples, nuts like pecans and acorns, which are true nuts, and sunflower, well, fruits, this is really a fruit, not a seed, the seed is the kernel that's inside, are indehiscent fruits. So these fruits are derived from the ovary wall, and they don't have an axis or a suture where they split open naturally. So even though you might put the sunflower seed in your mouth and crack it with your teeth and spit out the hull, these are not considered to be sutures. So these are indehiscent fruits that don't split open at maturity. Here's a couple of southern favorites. This here is a gumball, which is the fruit of the sweet gum tree. And this here is a magnolia, for lack of a better word, cone or strobilus. And these are two types of dry dehiscent fruits. They are both aggregates of follicles because they open along one suture. And there's many carpels that together make up these fruits. So technically speaking, a strawberry is a dry fruit because the achenes are actually dry. And it's the receptacle that it's fleshy. All right, so I'll close this presentation with this image here, which shows you again how double fertilization works and how we go from our sporophyte through the gametophytes back to a new sporophyte.